All right, here we are, video 2 of finding relative extrema. There are actually two tests that you need to know in calculus to find relative extrema. And one of them is the first derivative test, which coincides with the work you've done with increasing, decreasing. So here's how we're going to approach it. When you're looking for relative or local minimums, local minimums, we're going to create this process where we're going to find the critical points. Remember, critical points are wherever this first derivative is equal to 0 or undefined. We're going to create a sign chart, which is kind of what we were doing before. And we're going to check for values where the derivative changes from negative to positive. Because if you think about it, if we go from negative to positive, well, that's going to create a dip. That's a minimum. We're going to justify that is by writing a statement that says the function f of x, or whatever the name of the function is, has a relative minimum at x equals whatever the value is, because the derivative changes sign from negative to positive. That's it. To find relative local maximum, we're doing the same thing, finding critical points, creating a sign chart with f prime, and then we're going to check x values to see where f prime goes from positive to negative, because if it's going from positive to negative, well, it's going to create a peak or a hill. So we know that it's going to have the function is going to have a relative maximum at x equals whatever the magic number is, because the derivative of f changes signs from positive to negative. So here's the nice thing. If you understood and built those sign charts for the increasing, decreasing section, then everything is already kind of set up for us to use that process. We're going to do that with number 1, and then we're going to do that, with example 2, and then we'll do it at example 3. So let's do example 1. Got to find the critical values. How do I find critical values? By taking the derivative. So f prime is the derivative of negative 1/3 x to the 3, x to the third power. That's going to be negative x squared, plus the derivative of 3/2 x squared. That's going to be 3x, plus the derivative of 10x is 10, and the derivative of 3 is 0. So I have my derivative. That's awesome. But I want to know when this derivative is equal to 0. So I notice that it's a quadratic. Whenever I have a quadratic, that means I could try to factor it. That doesn't mean it's always factorable, but I could try to factor it. I do also notice that there's this negative here, and that's kind of bothering me. So what I'm going to do is I'm going to factor out that negative in order to create this. Do you have to do that? You don't. I just like my x squared term to be positive. It kind of helps me find that factors a little bit faster. So that means I have this negative on the outside. The question is, what does this factor to? This is still the derivative of f. Let's see. Well, I know this is x and x. I know I need two numbers that multiply to give me negative 10, but when I put them together, they have to give me negative 3. I believe that's negative 5 or minus 5 and plus 2. So if I multiply x times x, I get x squared. If I multiply negative 5 times plus 2, I get negative 10. And if I multiply the inside, I get negative 5x. Outside, I get positive 2x. But when I put them together, I get negative 3x. So yes, I think that's it. Great. Have I found the critical points? No. I just found my derivative and wrote it in a way that could help me find the critical points. The critical points, or the critical values, are x equals 5 and x equals negative 2. Those are the only place I'm going to label them critical values. Those are the only x values that make the derivative equal to 0. And there are no x values that make the derivative undefined. So I think I'm ready to build my sign chart. So when I go to my sign chart, here's my x values. I'm going to go ahead and label the x values that I just found. These x values are special. Why are they special? Because they make the derivative equal to 0. And now I'm going to pick points on either side, and we're going to figure out where this function is increasing and decreasing, because whenever it changes from positive to negative, the derivative changes from positive to negative, then I know that there's a relative max there, and vice versa for a relative min. So now we pick points. All right, well, let's pick a number bigger than 5, like 6. What is the derivative there? Well, I'm going to substitute 6 into the derivative. Don't forget about that negative in the front, though. So if I substitute 6 into the second parentheses, I'm going to get a positive 8. 6 in the first, I'll get a positive 5. So positive times negative will give me a negative derivative. So I'm going to make sure, since the 6 was just a representative from that section, you could have chosen any other number bigger than 5, and I'm still going to get a negative answer. I'll pick a point in between -2 and 5, like 0. Let me use a different color. 0. If I substitute 0 into the second parentheses, that's positive. 0 in the first parentheses, that's negative. So a positive times a negative is a negative, times another negative is a positive. So this is all positive in between. Any number between -2 and 5 will produce a positive derivative. And then let's pick a number over here, like -3. So -3 substituted into the last one would be negative. Substituted into the first one would be negative. So negative times negative is positive. But then don't forget there's another negative, so this is all negative. Great. I just figured out what my derivative is doing. But remember, I had asked that maybe you'd make a little sketch of what the original function is doing. Well, the original function is decreasing all the way until it gets to x equals -2. And then it's increasing. And then it's decreasing. So therefore, I can see that there's a dip here, a valley, so this is a relative min, and I see that there's a peak here, a hill, so that means there's a relative max. So I'm going to answer the question. It says find any relative extrema for f of x. So two things. Relative max at x equals 5 is, do I know what the max is? Well, I don't. What we can do is we can substitute the 5 into the original function, and then that's going to give us what that answer is, because that is the relative maximum value. That is the biggest function value, the highest y value, and it occurs at x equals 5. So I'm going to come back to that in a little bit here. So I'm going to leave it blank. The relative max at x equals 5 is blank. Or I could write the relative max is blank at x equals 5, right? But I'm going to say because relative max of f of x, let's be clear, the relative maximum of f of x at x equals 5 is, and I still haven't calculated it, but I'll come back and do it, because f prime changes signs from negative to positive. That's how I know that there's a relative max there. I'm sorry, positive to negative. My bad. We're talking about this area. We're talking about this area right here, right? There is a peak, and there's a peak because my derivative goes from positive slopes going up to negative slopes going down, and that's how I know that there's a relative maximum. I know there's a relative min. Let me change colors here. I know there's a relative minimum of f of x at x equals -2, and I know that it's some number because f prime changes signs from negative to positive at that point. And so I'm going to be open with you. I think most of the time when they ask you to find relative extrema, they ask you at what x value does it occur. So really, this statement would be everything you needed. This one, though, says find any relative extrema. So then we really should be looking for the y values. And that's why I'm going to go back and substitute these numbers into my equation to get the answer. So I think that's going to be what we're going to do here. But that's it. We're using the idea that we did before about increasing, decreasing. But now, since we can see with these little arrows, we can see where the dips are, we can see where the peaks are, then we know that there's relative minimums and maximums. And again, I have to have a change from increasing to decreasing, which is when the derivative changes from positive to negative or negative to positive, depending on which extrema I'm looking for. Okay. So let's see if we can do this really quick, and we'll stop video 2 after we find this. So let's see. Can we do this without a calculator? Is it asking for a calculator? I don't know. To the third plus 3 halves, 5 squared. plus 10 times 5 plus 3. All right, let's see if we can do this fairly quickly. 10 times 5 is 50, and 50 plus 3 is 53. Okay. 5 squared, that would be 25. 25 times 3 is 75, so this is 75 halves. Plus 5 to the third, that's 125, because 5 times 5 is 25, times another 5 is 125, times negative 1, that's negative 125 thirds. And so now I see if I'm going to put them all together and use a fraction, I think I need common denominators. So common denominator, let's see. Common denominator would be 6. Let's see. So if this already has a 3, I need to multiply this by 2. But if I do it on the bottom, I got to do it on top. So that's negative 250 plus the second fraction. I need a 6. It already has a 2, so I need to multiply this by 3, which means I need to multiply the top by 3. If I do that, I believe that's 225 plus this doesn't have a denominator, or it has a denominator of 1, so I need to multiply that by 6. If I do it on the bottom, I believe that's 318. I think I did that really fast. But now I can put all these together. See, this is what I'm thinking. They probably wouldn't ask you this because think about the time that it's taking for us to get an answer. I will say this. If you're writing on a free response question, like you can box this and say, that's the answer. That's where the relative, is this a maximum? That's where the relative maximum happens. You don't need to simplify, right? So on a free response, you don't need to simplify. We could have stopped there. But we have time, right? Let's keep going. Negative 250 plus positive 225, I believe that's negative 25 plus 310 over 6. And now I can put these two together, and I believe that is 293 over 6. I believe so. So this would be your your relative max. So that would be what I would put in the blank here. 293 over 6. Again, assuming I didn't make a silly mistake somewhere. And as you're watching this video and you can see the silly mistake, well, I'm sorry. And then I'm going to do the same exact thing to find the relative min. But you get the picture, right? Like you were just plugging it in. I'm going to look into whether they expected us to actually find the y value, or if we could have just left it as this, which is normally what they ask us to do. But I'll check. When we come back in the next video, we'll do example 3, and then we'll get a little bit easier, quote unquote, by looking at some graphs that might make things go a little bit faster. But we'll pause here and we'll come back.